this is the paper, Identifying and Treating Unobserved Heterogeneity with Phimics Part 1, Part 2, a case study, etc. Discovering Unobserved Heterogeneity in SAM 2013, and that's 2015. The basic point is that all of us believe that data is coming from the single homogeneous population. So we admit that yes, my data may be different for boys and girls, public sector, private sector, demographic variables we have measured, and it might be different for that. I'm not talking about that. Basically, see, let's talk about the diagram. Heterogeneity is there on the basis of non-source, which you already say that data is different on the basis of demographics, or there may be unknown source that you don't know. Okay, so so if you consider all the girls of your class, all the girls of MBA first year, so you will find that roughly their age is the same, their gender is same, their marks are almost same, their socioeconomic status is largely same, but still you will find people are different. So there is one concept in marketing. Marketing, basically the three keywords are STP: segmentation, targeting, and the positioning. So segmentation concept says within a market there is a sub-market. There is always within a market there is a sub-market. Like all the people are not the same. The people who purchase any particular toilet soap, they are not looking for one soap. That's why we have soap for the oily skin, for the rough skin, for the ordinary. Then in the ordinary, not people are all the same. We make it for 75 gram, 100 gram, 125 gram. In that, again, there is in 75 gram, there is again for this particular fragrance, this fragrance, this fragrance. So we try to go into the, this is called as the product depth. How many variants are there? So why variants are there? Because for every market, there is a sub-market. See, earlier, I think 30-40 years back, it was so simple life in India. There was an ambassador car and there was a Fiat car. That's it. And ambassador car means there is a one car. But when the Maruti and the Hyundai and others came into the picture, now there are so many variants are there, so many brands or models are there. Within that, there is a LXI, VXI, ZDA, so many, because if you look from here to here, all segments are there. So how to find out how many segments are there in my target audience, in my people, my sample? So one method is go along with the cluster analysis. In the cluster analysis, the purpose of the cluster analysis is it identifies not on the basis of demographic, but on the basis of psychographics. So we ask some psychographic questions. Have you noted some of the time we say to our friends, you know, this person right from he was never young. He was an old age person right from his childhood. Their thinking pattern is such, some people are just, you know, much ahead of the time. Some people are much behind the time. So the psychographics is the way, not the demographics, but the psychographic, the way your brain functions, the mind functions, you look at the life. That's psychographics. We make the psychographics and the clusters on the basis of one technique called cluster analysis. Demographic, that's everybody know. Sometimes a demographic also work, like Johnson baby products. It's only used for the babies. There are a number of women product used only for by the women, men product. So that's okay. One thing is we can divide on the basis of demographic. But the point is, after some time, you will feel that no, not I'm talking about some cosmetic items. Why all the girls are not buying the exactly same cosmetic items? No, again, there is so many varieties are there, so much the requirement is there. So again, we come back to the psychographics. Psychographics means the way you think, you look at the world. But the problem with the psychographics is here there is no concept of dependent independent variable. Absolutely not. There are these statements and we simply look for a formula. Do you remember this formula of coordinate geometry? X1 minus x2, the distance between the 2 points is given by x1 minus x2 whole square plus y1 minus y2 whole square and under root of all of this. So we need to find out the D of all the people who have given their answers. We find out the D and we find out wherever the D is minimum, those people we club. These are the people who think alike and these are the people who are different. Within them they are common, but they are different from this cluster. We make the clusters. But when the case is of dependent independent variable, we cannot use the cluster analysis. The assumptions are violated. Now here, when there is a concept of dependent independent variable, we use either the Phoenix procedure that's available in the SmartPLS, or we use RStudio, and then there is something called the Rebus. So in the RStudio, there is one package, PLSPM, a wonderful package made by Professor Gaston Sanchez. Gaston Sanchez, he works in California University. So he made this PLS package. You can do almost all the things that you can do in SmartPLS. Almost, not 100%. So you cannot work on the common method biasness. As of now, you can't, but maybe he will add this. But very, very simple. PLSPM package is, as compared to the rest of the RStudio, simply 3-line code is there, and it will give you all the information that SmartPLS gives you. I have a playlist on the PLSPM also. Now we'll discuss about both of them. So basically, what is the point? Basic point is, now I am talking only about the structure part. I'm not talking about the measurement part. So where we are exactly, can we see in the research process? Yes, we started with variable. We studied the variable. We went for the structural literature review, or you can call it as a review of literature. We formulated some sort of hypothesis. We took certain, after hypothesis, you get some sort of, rationale for the study, need for the study, formulated some objective, and then you went for the research design. In the research design, including the sample design, you consider that marker variable, I will be measuring marker variable. So now it comes for the data collection, where you measure the marker variable. You go for the, after data collection, you go for the data cleaning. You see if there is 5 sort of problems are there. I have explained it in a separate playlist. The problems are outlier, non-response, missing value, logical error, category merging, improper coding, typing mistakes. So these are the part of data cleaning. After data cleaning, now I am asking you, please stop. Don't jump directly to the data analysis. Don't jump directly to analysis. How come you know that this is what I'm calling here as the model robustness? You will not find this in the books. You will not find in the papers. It is just on the basis of very recent papers. I have updated it. You check. Basically, I'm checking the assumptions. One assumption is my variables are linearly related. That's why you are working with SPSS, MOS. But how do you know this is a linear relationship? How do you know? You believe that you have all the people, this data collection is very, very homogeneous. All the people are alike. Now I will show you, and I will ask you to do it even in your published work. When you say R square is equal to 41%, you might see there are the 3. For the one, you will find the 10% R square. The other group, there will be 90% R square, and third, it will be 70% R square. So it means for this particular group, the real IDV leads to DV doesn't matter. They give a damn to that. And these people are something like cause and effect. When IDV is there, DV will be mandatory there. R square, 90%. And here it's a reasonable. Only thing is when you put all together, it comes to the 41%. So only, when you understand this, then you will come to know what we were doing earlier and how sane it is to do this when there are people are saying so many different things. People are saying so much different things, but you are not listening to them. If you listen to them, you will find, yes, this is a remarkable thing. So what we will do here, we will use the Phoenix procedure. Phoenix is the finite mixture regression. We will determine the number of the clusters. This comes a big point. How many clusters should I get? So by default, there is a one cluster. 400 data, 400 data, for 600. There is only one cluster because you consider all as the one. It can be more. Examine the latent segment. We will make some sort of the segments here and specific segment. We'll come to that. See, where is it available? I have put some sort of screenshot. So it is available here. If you click on this PLS of simply as a calculate, you will find here PLS algorithm, etc. Finite mixture segmentation. So click on that finite mixture segmentation and you will see menu like this. Now by default, it will say you number of segment is 1. Obviously, entire data is taken as the one segment. Now you need to tell how many segments you require. And that comes a problem. How do you know how many segments are there? Is it just simply going 1, 2, 3, 4? Partly, but how to get maximum number of the segments? We have method for that. We will calculate the K. What is the value of the K? K means what is the maximum number of segments, number of clusters I will check for. How to find out the K? K is sample size and divided by minimum segment which is required by the power analysis. Now, what is a power analysis? There is something else called G power. Okay, your troubles will never end. So there is one more software called G power. I have used G power 3.1.9.2. It's a software from the open source, very small software. You download it. It's used only and only, the purpose is to calculate the sample size. So does it mean we calculate sample size using G power only? No, there are two methods. One, you can use complete processes there, and second, you can also use using the G power. Both methods are very prevalent, and if you look at here, I have two playlists. One playlist is about sampling design. So in the sampling design, you will find there are n number of videos. Okay. So first go through these 6 videos. There's a complete process. We always start with people say, well, what sort of formula I should use? Never. It's a wrong question. You first go through these steps. Steps will say, first there is a population, finite, infinite. Then there is a sampling frame. Then there is a sampling unit. Then there is a sampling method. Then sample size. Sample size is of 4 types. Which type, what work you are doing, just go ahead with that. There's a complete process. And then there is another process. First you determine a sample size. Then you increase it because of the non-responsiveness. And then you further decrease it because of the common finite population correction. So these are again very common sense sort of thing. It's not technical. If you have not done it, that doesn't mean it's a technical. It's only thing is you have not gone through it so far. That's it. Nothing more than that. Then this how actually to do, what is sampling, random sampling, stratified cluster, multi-stage, etc. There was one webinar I have taken. Some frequently asked questions are there. In this webinar, so there is no thing discussed. It's only question and answer. So some very frequently asked question. And then another is there on research methodology, which I was saying in morning, you must watch initial 5-6 videos. And in that video, if you go here, we have something called, below it, it's a G power. So G power, it's the concept of hypothesis testing, type 1, type 2 error, how to evaluate all hypothesis testing decisions. Then this G power software, you download it. So after downloading, you will see something like it. Can you see it? G power, where is it? G power. Now this is the software. Let me minimize all and come to the G power. Okay, so I need to discard. Okay, this is the G power software. A very small software. You download, it's a free of cost. It says test. It works on the t-test family, f-test family, chi-square z-test family. So we'll work on the f-test. If you are working in the structural equation modeling, you remember there's a structural part, independent, dependent. In that you go from here, there will be a concept of linear multiple regression fixed model. Linear multiple regression, a priori. A priori means I have not started my work. Please tell me how much sample size I should take. If my model is clear to me that this much is independent variable, this is dependent variable, if I'm clear about that, then it will ask you 2 things. How much alpha you want to maintain? Alpha is always 0.05. How much beta? A minimum limit of the beta is 1 minus type 2 error, 1 minus beta. So how much power do you require? Power generally we take as the 80%. And if I'll say like predictor is 2, you put how many are there and click on the calculate, it will tell you that total sample size is 68. That is required. With the required this, you will get a power of this, alpha of this, effect size of 0.15. It's a minimum moderate effect size. Like see, effect size up to 0.2 is small, medium and large. On the basis of it, it's a priori. A priori means before starting your work, you can think of how to calculate that. And mind it, G power is a software. every single person, whether they are the professor, just a scholar, everybody is using it. Worldwide accepted in every country, in every field. G Power is a very, very wonderful software. So how I require it? So it says if you have two predictors, there must be a sample of 68. Now my sample was actually more than this, absolutely no problem. If you got a larger sample, then actually it's a good news. So what we will do, this is the G power. We maintain this is almost standard. You go for the simple. First, you go for this t-test or f-test, whatever, linear multiple regression fixed model. In that, a priori, and now they give the value alpha is 0.05, power is 0.8, and mention how many predictors you have. And then you will get the power of 55. Now, just see here. What I will do, I said I got a data of 243 divided by minimum cluster should be of 55, not less than that. That is given to me by the power analysis. So I divide roughly 4 clusters I will check. So how we will do that? You will use the G Power software to get that what should be the minimum cluster I should have to get a meaningful means alpha of 0.05 and beta of 1 power is 1 minus beta. Beta is 20%, 1 minus beta is called power, that is 80%. Alpha is 5%, 1 minus alpha called level of significance, that's 95%. And on the basis of that, you divide your sample size with the number of clusters, minimum size for one cluster, and you will come across with the 4 clusters or whatever, 3-4 clusters. Now I know, so I will click on it. I will run for finite mixture. I will say 1 cluster, or actually you should start with the 2 cluster. You may start with the 1 cluster because it might be there are no clusters. Start with the 1 cluster, value is 5000, click on it, 1, and here you need to see, here you need to first, by default it will not be activated. You should put the stop criteria 1 less and then again 1. I don't know why they have done it this way, but then click on the start. By default, start calculation is not activated. You need to click it once, make it to 9 and then 10, and then you can click on the start. You will get value like this. What is meant by this? We have here fit indices. Okay, come to the fit indices. These are the indices we will take. Now here the indices does not mean like AIC, BIC, etc. It is not like CFI, GFI value of this is high value or low value is good. They are comparative indicators. So what we will do, you will just take the fit indices and there is a segment size. It will tell you how many people are there in every segment. We require, just to knowing how many segments are there in my data, we will go for the fit indices. Let me show you once again from the back how we have started it. We will talk about the Phimix. In the Phimix, basically it will ask you how many segments are there. I don't know how many segments I should check. I can randomly check 1, 2, 3, 4, 5, 6, 7. But what should be the upper limit? For that, we will use this G power. G power will tell you on the basis of given alpha, power, effect size, and number of independent variables. It will tell you only independent, not the mediator, not the control variable, only take the independent variable. How many independent variables you have? On that basis, for the given alpha, power, and effect size, it will give you, this should be the minimum size of one cluster. So now you know that this is the size. Total my data was 243. So like if somebody got 100 data of 100, then only 2 clusters can be proposed. If data is 500, then up to 10 clusters can be proposed. Okay, because a cluster should not be less than 55. Up to this, that's a meaningful. Now go back again to this finite mixture, and this time start with 1. We will repeat this process with 2, with 3, with 4. 4 times we will do it by changing the cluster segment. Here in the stop criteria, you need to make it as 9, or maybe you make it as, you change this number and then again come back to 10. Maximum iteration 5000, whatever default value, click on the start, and then you will get these values. You see here it's written data group complete next. If you click on the next, it will show you the value of the next cluster, etc. So you can see complete value. It's as if your file is split. You can see the value of the one cluster, you can see the value of the other cluster. But for the time being, we don't require these values. We require fit indices. Click on the fit indices, click on the Excel format, copy and paste it there. Then do it again for 2 cluster, do it again for the 3 cluster, and make a report like this. I have made this to cluster 1, cluster 2, cluster 3, cluster 4. Now this is the most important thing. This will tell us how many clusters we have. How to find out how many clusters we have? Now there are certain criteria given, AIC, BIC, AIC3, etc. So look for these criteria. AIC will always tell you AIC is the upper limit. It overestimates. So how many, whatever cluster AIC will tell you, it will be either that or low. So AIC is the upper limit, either this much or lower than this. Just like MDL, this is the lower limit, either this much cluster or more than this. And this AIC3, etc. will decide how many clusters are there. AIC and MDL will give you the upper and the lower limit. Let me tell you how we'll do that. I will come to this. Please see this. How we'll do? We will take this table and find out the minimum in all the table. You have to read it row wise. Find out which is the minimum in the AIC. Minimum is 1615. So according to AIC criteria, there should be 5 or low clusters. AIC is always the upper limit. AIC will tell you that either there are 5 clusters or there are less clusters. Okay. Then go with MDL. MDL lowest value of MDL is in the 1 cluster. So MDL says either there is a 1 cluster or there are high clusters. To get the limit, 2 limits we get. AIC will give you the maximum number of clusters. How to read it? Number 1, I have to run it again and again for cluster 1, 2, 3, 4, 5, maybe 6, 7, and then find out AIC, what is the minimum value? Minimum the value, better these indicators are for all of them. So the best value of AIC is in cluster 5. So it tells me that either number of clusters should be 5 or less. MDL always gives you minimum description length. It gives you number of clusters should be this much or higher. It is the minimum limit. Now, okay, we understand either 1 or more cluster, 5 or more cluster, but how to determine how many cluster? For that, we will use now the rest of the indicators. AIC is okay. This is the upper limit. MDL is the lower limit. Now see, AIC and CAIC. If any of their minimum value is in the same cluster, choose that many cluster. Let me see. AIC, the minimum value is in the cluster 3, and check it. It is paired with CAIC. CAIC is in 1 cluster and AIC in this cluster. So we can't deduce anything out of it. If the both values are in the same cluster, then we'll say this much cluster. If this doesn't work, then go next. If this doesn't work, then go for the next. AIC4 and BIC, check them. AIC4 recommends a minimum cluster of 1 and BIC recommend a minimum cluster of 1. Both fall in the minimum value, fall both of them in the same cluster. So we conclude we have the 1 cluster and there is no effect of heterogeneity at all. Now you can go ahead with the routine, but you must show this table. This table shows that I have actually checked whether there is any sort of segmentation or not. In this data set, it shows no segmentation. So let's quickly go through the process, how we are saying it. Number 1, we assume that there is some sort of heterogeneity, unobserved heterogeneity, let's call it as unobserved, because I don't know. There might be some of the sources I know. These are the demographic variable, but unobserved heterogeneity. I will use the Finite procedure that is given in the SmartPLS. How to go ahead with? First, it will ask you how many clusters. And the formula for the cluster is sample size. Whatever is your sample size you have collected on some basis divided by k. What is the k? K is the number, you get it from the G power. It is the minimum sample size for 1 cluster required. So work on the G power with multiple regression, give alpha 5%, beta 20%, 1 minus alpha will be 95, 1 minus beta called power of the test, with which name the software name says G power. Effect size 0.15 and number of independent variables you define, it will give you the minimum value of segment. Sample size divided by this value will be called as K. I think this is called, let's say C or N, called as something else. This much cluster I will check. We will go for the Finite procedure, run with the 1, 2, 3, 4, as much as this number is there, K. After this, find out the what? Model fit indices. So model fit indices you check. AIC value is always the upper limit. MDL value is always the lower limit. Now check it. AIC3 and CAIC, if they are the same, they are pointing out the same cluster, take that. If not, then AIC4 and BIC, I hope I have written them correctly, take them. So AIC4 and BIC, how to check them? For each you have to go read it row wise. Which indicator suggests which cluster, which minimum value is the best one. So AIC suggests there should be 5 or less clusters. MDL says there should be 1 or more clusters. Check AIC. AIC says AIC3, it says there should be 3 clusters, but CAIC says there should be 1 cluster. We cannot deduce anything out of it. Go next. AIC4 says there should be 1 cluster. BIC says there should be 1 cluster. Go ahead with that. And lastly, there is something called entropy. Entropy preferably should be greater than 0.5 for each. At least the clusters you are getting. So check out, yeah, that is very less. This is less. This is good. 3. Entropy greater than 0.5. Here is greater. Here is greater. These two are less in the entropy. Now, point is, even if you use this procedure, the authors say, well, that's one of the procedure. You should not depend that this is the only way. They should make sense also. Some other time, what happens, you make 5 clusters. Some clusters are of the 60, 30, 5, 2, and 1. Now, it means in one cluster, there is only 1 person, 2. This is meaningless. If that is the case, statistically, that's okay. But practically, that has no meaning. Such a low cluster, no. They should have some sort of meaningful. And then, if simply we say there is a cluster, it won't help. So we must know that which person go to which cluster. So SmartPLS will give you that also. Which person will go to which cluster. Now, so that you go back to the file and check it out why these persons are in the same cluster, whether they are from the same place, they are from the same school, same age group. You try to find out what is the characteristics. This cluster will simply tell you mathematically these people, their responses were very much similar. Their behavior were very much simple. And you will find it totally shocking results. This cluster, and this is something like day and night. What they are saying, sometimes you will find X got a positive effect on Y, and other cluster you will get a negative effect of Y. This much variations are there. And you yourself are shocked when you see what is going on in my data. I never knew there are so many people are thinking this way, other people are thinking this way. So using this PMIX, you can actually, and again, you tell me whether you should do it before the analysis or after the analysis. I recommend it doing before the analysis because you know they are the different people. Try to have it. Now you will maybe looking from the PMIX, you will go back and say in the research methodology that we looked for 300 people, but we thought all will be same. But later on it was observed there are many sort of groupings. I identify who are the people, I put them into a group, and let me give my data analysis for separate group because I know they are the separate group. Let's assume they are the just like the separate groups I have taken. These are results are separate, these are separate, and then write the reason why these people say negative and these say positive. This will be really add value to your work. So in this case, 1 cluster. So I conclude here no heterogeneity is there. So then what to do if number of clusters are more? Then what you will do, you will save that cluster membership. It will tell you. Then again go back and apply the MGA, multi-group analysis. Okay, cluster is only one thing. Just like consider that a cluster just like a moderator. Go for the multi-group analysis and try to see whether they are different or not. Now check it out. This will give you here cluster assignment, and here it will give you which person will go to which cluster. So like first person go to first cluster, second go to the first. You can copy it, save it in your file, and then along with the rest of the demographics, you can wonder, you can check why these people are same, why these people are different. Okay, so I put it here, and then I imported that data file, went for the multi-group analysis, and then partitions, etc. And now let me show you the result, what the result will come out. See, this is the complete one. If I look for the complete one, look there, effect of quality on loyalty is 0.4. This is for taken all the people. and effect of satisfaction on loyalty is 0.428. Okay, let's go for the first cluster. It's 50, 0.5 and 0.2. Okay, check it out. Next persons, it will be different. So I made this complete table here, and in that table, this is original data out of 243. If I'll go for partition 1 with 137, if I'll go for partition 2, that means how many people are there? 137 and 146, 56%, 44%. Look, relationship are almost significant. Are they exactly same? Here, 0.48, 0.34. Check it out. This is, I want you to check this. This is just amazing. 50% quality leads to loyalty. The effect is 0.5, and here is almost 0.1. 5 times is the effect on this cluster as compared to this cluster. Check it out. Satisfaction leads to behavior, behavioral intention. Almost 10 times is the effect here. In this cluster, for these people, it's 0.68. For this, it's 0.06. It's almost how much time? 6 times or 10 times is the effect of this. How can you believe that this is one cluster? How can you report as 283 when some of the people say 0.06, almost, and mind it, it's negligible, it's not significant. For these people, it doesn't matter. Satisfaction does not lead to behavioral intentions, not at all. For those people, it's very strong evidences that satisfaction leads to behavioral intention. Look at this, satisfaction lead to loyalty. U says for a total of 4 to 8, but actually is somewhere it's 0.2 and somewhere it's 4%, 0.8. You know, once you know about the segmentation, you will never ever dare to report the for the and on the total data without checking. Check it out here. This is the R square value. R square value, check it out, 26% and 90%. Can you believe it? 90% is something like cause and effect. Whenever this will be there, behavioral intention, this will be there. Look for the others. It's 19% and it's 48% or something. 40%, 39 or 40, 88%. Can you look at the R square? How can you say, how can you report this data now that these are all people are same? They are not same. There is one cluster, there is second cluster, and these are total miles apart. Total different people. So this is structure relation are almost the same. Measures are also same, but huge fluctuation in R square, particularly in groups, and you will write, you'd like to write their reasons, why they are different, and you will certainly find those reasons. So first, let's, this is one part we have completed. POS is a second part, predicted oriented, but first let's try to see how to do it actually in SmartPLS. Before that, if any questions are there, do you understand what I'm saying about? I will request organizers to please open the chat box so that people can ask their queries, and then I will show you how to do it in SmartPLS. That's not a big deal. What I will do, from G power, I calculate a cluster size that I computed 55. I will go for 1, 2, 3, 4 cluster, run it 4 times, click on the Fimix, give the cluster number, run it, copy the goodness of it, put it into the Excel table, find out where is the minimum value. From there, we will find out how many clusters are there. Okay. Will take much time to understand and applying. No, Prashant sir, it won't take much of the time. Rather, Prashant sir, I will ask you that whatever data, whatever paper you have published, okay, you have that data, you have the published work, take that data once again and try to see if there are any clusters. Your eyes will be opened and you will be shocked to see that actually when you say 24%, some of them will say 80% and some of them will say 2%. And actually you should have said that these are the different people speaking very differently. When I checked it, it was very different. Can you explain the effect size? No, I will not explain. You please go to my videos. There I have already explained. There is a, you simply write Neeraj Kaushik effect size. 2 videos are there. I have explained in much detail, everything. Yeah. So my friend Dr. Sandeep told me these things, which you are saying, Prashant sir, that after collecting the data, do data cleaning and never jump to the data analysis. First, go for the cluster, go for the checking for the unobserved heterogeneity, and only then you should take the all the different people differently. It's something like, see, Prashant sir, when you go to the hospitals, all the doctors don't treat you the same way. They ask you n number of observations about you. Do you have a sugar? If you have a sugar, the treatment will be this. If you don't have sugar, treatment will be this. Do you have a medical insurance? If yes, treatment will be this, else treatment will be this. For every single thing, they don't treat. You go to any, I'm talking about, let's say, dental doctor or any sort of gynae doctor. They never say that all the people are the same. They always look for the no same. This is separate, separate, separate. Try to do that. And this is precisely what we should also do. This is an assumption. Once you understand this, you can now understand this was just a mere assumption. All people are the same. And if all the people are the same, if show it mathematically, show it statistically, you get added advantage that yes, I checked that and all things are the same. How IPMA is different from this? Okay, Vimla, IPMA actually talks about two things. And you really don't require SmartPLS for that. You can do simply with the help of Excel. First thing, IPMA, do you understand what is meant by the R square? How much a variable is explaining the dependent variable? That is the R square simply. Okay. And the other thing is, what is the beta? What is the beta for every single one? And second is about the mean. On the 5-point scale, what was the mean of everyone? One is importance and one is performance. Performance one, when I measured it, let's say 5 construct I measured for service quality, tangibility, reliability, empathy, etc. Which one were the good performer? Which one were the poor performer? So might be in my college, I have the wonderful tangibility, but poor reliability, or good with the assurance, but some other variable. One is performance. Second is looking from R square, please check which one is important. So it might be possible we are not giving any attention, which is, we got a very poor scale. IPMA means importance, performance. So where you should focus as a marketer, as a policymaker, where you should focus? You will say we should focus one that is important. So if there is anything that is not important and you are focusing a lot, how does it matter? I remember we have done a study 10 years back. It was on bike, and we asked which are the things which are very, very important. So we find fuel efficiency in the bike, mileage, price is important, maintenance is important. Color of the bike was found to be the last one. Color of the bike. At that time, I remember there was one MLM. I think they were giving LML Freedom was the name of the bike. They were giving 8 to 10 variants of the color. They are focusing on something when people don't require. People say fuel efficiency should be there. The important one should be how you are performing on the important one. That is IPMA. Nothing to do with the heterogeneity. Totally different concept. IPMA simply says what are the things which are important, and then see in each one of you how you are performing in that. That's IPMA. You can do it in Excel. Actually, in my video, I have shown on Excel, and then in SmartPLS, you click, it will be done, but you can do it in Excel in one go. That's not an issue. Amrita asked, do I have to check cluster first and then data collection? Oh, no. Data collection first and then cluster. I am applying cluster on the score. If you don't have a score, how will you go for the cluster analysis, Amrita? First collect the data and then you go for the clustering analysis on the basis of that. And then you go ahead with the further. If you are working on the women entrepreneur, I can bet not all women entrepreneurs are exactly same. There is no model coming like every women entrepreneur will be same. They all have the different challenges, different life, different experiences. You might feel, I am saying again and again, I am not saying that compulsory there will be clusters. I am saying there is a great chance that there will be clusters. If there is not coming up, like in my data I have shown you, it says only one cluster. That's a good news. Go ahead, report it that I checked and it was found to be the similar. But it's a complex to decode. Yes, I still say here takes the form of D. D means how much distant they are. Those who are very near, they are clubbed, and those who are away, they are kept away. So cluster also makes sense. Ritika says, if I have already done demarcation in the sample base of demographics and computing cluster with Physics, should I report the result according to this? Okay. That's a very wonderful question, Ritika. I told you that clusters are made first on the basis of demographics. That's okay. My question to you is, Ritika, if you take all the girls that belong to the same age category, for example, take the MBA first year girls. MBA first year girls, their age is almost the same. All are the girls. All have almost the same marks. All have the almost same the family income. Or take away those who are very away, remove them. At least 10-15 girls will be there who are exactly same in all demographics. All demographics. They must be using the same cosmetics and doing everything same. Point is, are they exactly same or still different? Psychographics says they are still different. If you ask for their choice for what sort of dinner they will they take Punjabi, continental, or Italian? Their choice may differ. Their n number of products they will buy, the airlines, etc. They might be differ. Simply demographics don't make us same. Demographics don't make us same. All research scholars, if I'll start believing all research scholars are the same, no, they are not. Though they are not. They are one. You can okay in first year, second year. Yes, it can be. You can talk in terms of okay from management, commerce, economics, engineering. Yes, they can be different. But within engineering, first year, not all are the same. I'm just saying, please check it. And then when they are the different, again, Ritika, we will come back to demographic. If I am told that, okay, Shraddha and Ritika are very much similar. So what is similar? Names are not similar. They Shraddha, Ritika. What is similar? Age is almost same. I will try to find out what is the common thread in all of this. What is the commonality in all? And again, remember, we are affected by n number of things. Maybe I am doing it because I love my father. Ritika also love my father. That's why our behavior pattern seems the same. Then we will try to find out that particular very reason why these people are all the same. That's what this segmentation is all about. But when you find the clusters are there, you will definitely report and you will definitely go back to the demographics and try to see what are actually the differences between them, which otherwise are not able. Ritika, sorry, I'm not able to read your complete email. Not possible for me. Write short queries. So let's see how to do it in SmartPLS. Now this one cannot be done in Amos. This is done only in the SmartPLS. But yes, it can be done in RStudio and with great ease. Here we require an n number of things. And why two methods are there? One is Physics. Segment is, what was the name of the second one? I just forget. Pos. Prediction oriented segmentation. They two actually work on the different algorithms. Pos doesn't require any statistical. This is more on heuristic basis, common sense based. First one is on some basis. And Rebus, given by Professor Gaston Sanchez, that's very, very simple, extraordinary simple. So before that, there's a question from Pooja. If I develop and validate a questionnaire, can it be done through PLS software? Well, not related with this workshop, Pooja. Jubin, sir, does it mean that parts or simply increase our sample? Oh, okay. Jubin, I'm not saying you need to divide your data into two parts. I'm not saying that. I'm just asking you to check if there are any clusters. If the result comes no cluster, go ahead with the usual method. Report it, I checked and no cluster. That gives you added confidence that my people are alike. There is no chances that people will behave differently. If there are clusters, report there are the clusters. Again, go back to the sample retrospectively. And while you are working on the sample, write one line, a sample of 300 was taken. But when we checked for the using Physics method, 3-4 clusters are found. And now I try to identify what are the demographic things. And these are the one cluster, second and third cluster. Define it there in the sample. And in the data analysis, again, write that we thought of working with this 300 people. Since 3 clusters are found, let me try to give data analysis separate for all, because this will be just like day and night. Somebody will say 7% R square, somebody will say 97% R square. So tell them every objective, tell them separately as if they are for the separate sampling unit or separate sample size. Report it differently. It simply increase our sample size if number of cluster increase. No. Jubin, it's not that your cluster size will improve. It's the reverse. First, you decide your sample size with the usual formula. You must be having any rationale for taking that much sample. That's a 6-step process. Start with the population, sampling frame, sampling unit, sampling method, and sample size formula. Go with that method, and then increase, decrease, increase, that sort of entire process. Once you have that, depending on how many number of variables are there, G power will suggest to a cluster must have a minimum of this much sample. Total sample which you have collected, you have done that data collection, divided by the minimum sample required for a cluster will give you the number of cluster. Okay, so it might be actually depending on your sample and depending on variable, cluster will differ, but sample size will not increase. You have collected the data and now you are working with it. Okay, how to divide a file on the basis of cluster for analysis? Okay, ma'am, that can be done in 2 ways, ma'am. If you are working in SPSS, there's an option of split file. That's very, very simple. You simply go for the split file, run something, and it will give you separately. Let me show you, ma'am. That's a very simple thing. I have put a video on of the same. For example, here in this file, ma'am, hope you are able to see my screen. I have done it as saved the score of quality loyalty. I can save it using MOS, using SmartPLS. I can save this. I saved it. And now I want to see whether the quality leads to satisfaction. Is it same for boys and girls or not? How can I go? Data, split file. This I am doing in SPSS. Gender, compare group. Now, whatever you will do, it will be compared separately for boys and girls. If you can see my screen, ma'am, look at just above where the time is written. It says there is a box called split by gender. Right side bottom, just above my system time, it says split by the gender. It is a message. It means if I'll ask any simple thing, I ask what is the mean of satisfaction and quality. Descriptive. Tell me what is the mean of quality and satisfaction. Now every single thing it will tell. For male it's this much, female it's this much. Whatever you will ask, as if they are the 2 separate files. Let me run regression. So linear regression. In the linear regression, I say that satisfaction depends on quality. Okay, nothing else. Simply click on OK and see for the boys. Now it's really interesting to see. For men, R square is 27%. For female, it's 0.000. How will you address it, ma'am? Why girls, even when provided best quality, they are not satisfied, but boys are very satisfied. You give a good quality, boy is satisfied, girl is not satisfied. Maybe girls would like to explore more. At least my data is saying this. Female R square is 0.007 and male it's 0.27. Every single thing that's separate. Female, actually it's not significant. So quality, good quality, a girl will be happy. I couldn't show it with my data. My data doesn't say it, but boys are they are very happy. You give good quality, they are happy, not with the girls. One, there is a relation, other there is no relation. This is this much. How can you just take the data and say, okay, sample of 300 are taken and go ahead? So either this way, when I'm splitting, ma'am, this will be called gender as a moderator. Gender as a moderator, because you can see being a girl, being a boy or girl will also have an effect. And mind it, if I don't split it, let me take the entire data. And if I run the regression, you will never ever come to know about these things. Your point will be R square is significant, 20%, and go ahead. All the people, they feel good when quality is there is a satisfaction, and R square is 20%, and every other indicator is good. You will never be able to report the truth if you are not suspicious. If you don't check it going with the extra mile, you will not be able to. You just be happy with the data. But when you take something moderator, etc., then things will be slightly different. I'm not asking you to do, don't report, don't write, and just do any sort of your data mining. I'm not saying that. There must be some basis why you feel that gender should be a moderator. What is the basis? Why you have not taken income? Why you have not taken the place you belong to or other variable? There must be theory, ma'am. Theory is must. That's a mandatory. Only then you will be able to write. But we can do it this way. If we analyze clusters separately, how can we justify the generality of result? Vishwas, please see how can you generalize when there are so many clusters? Shouldn't you generalize for every cluster? It means you are saying entire India thinks this way. Shouldn't, want it to be better? You say that people of Haryana think this way, but people of Punjab think this way. People of Jharkhand say this way. Want it to be better? How can you generalize when you yourself know there is a so much complex thing and you make one generalization? Won't it be wrong, Vishwas? I think generalization means for that segment generalization. Boys think this way, men think this way, girls think this way, ladies think this way. You generalize as per the segment. Don't generalize for all. That's a dictatorship. That's not good. You are putting all people just like alike. That's not a good way. The generalization should be as per the segment. Data in the form of ranks given to various preference. Can Fmix be done, Ritika? No, Ritika. I am talking here about scale data. So basically, SmartPLS or AMOS works for the scale data. Ritika, please try to understand that. When you have taken the rank data, then only three things are there. I have explained it in my videos. You just watch those videos. Handling ranking data. Two videos are there. The three things are you take the average and say minimum the average better it is. This is one thing you can do. Second, you can check whether the rank differs significantly on the basis of demographic, etc. Apply the U test, Mann-Whitney U test, Kruskal-Wallis test. And third is we can use the multidimensional scale. With the ranking data, these things are possible. So, Ritika, try to understand this analysis. Something like it seems like Ritika, you got something and you want everything for your data. You are not ready to understand the overall concept, the things, or appreciate that. Somewhere it seems like, this is my kid. Can my kid go for swimming? Can I equipment? You got one ordinal data and you want everything in the world to be done with the ordinal data. I don't appreciate it, Ritika. I'm not very happy with this question. Dr. Sangeeta says, I want to know in male, female. What do you want to know, ma'am? Question is not clear. I want to know in male, female. I don't know what you are saying. So let's see how to do it in cluster. No, but then it won't be cluster, na, ma'am. See, I told you there are the two sort of, one known source of heterogeneity, second is unknown source. When you say male, female, that is a known source. We know that the boys will be different and girls will be different. Their result will not be same. That's a known source. If it's a gender, then call it as the known source is called as moderator, ma'am. Which you don't know, which you can't perceive. Only from the response pattern you will come to know these people think alike. Sangeeta ma'am, think of a scenario. 50 people are students are sitting in your class. One method is, as a conventional teacher, you can say girls on this side, boys on this side. Okay. Further, you can say hostler in the front and day scholars on the back benches. Okay. 4 segments are there. You can very distinct. You know there are different on the basis of hostler, day scholar, boys and girls. Okay. My point is, ma'am, within all the hostler boys, all are hostler, all are boys. Do you think all are the same? Okay, your known is done, that gender, etc. That's known, that's moderator, qualifies for moderator. But here I'm talking about, now you take the response and see whether they are alike mentally, and you will find maybe a boy's hostler and a day scholar girl, mentally they are very much near to. Their thinking pattern resembles, their frequency level is the same, or anybody will resemble with anyone. Have you not seen, ma'am, some boys, uneven pair, have you not seen that? I have seen so many pairs. A 20-year boy is a very good friend of a 80 years old person. They every day they meet in the park, they talk a lot, and they are very good friends. One is 20 years, one is 80 years. They should not be. Their age is different, but they are very good friends. Their frequency level matches. They can talk on the same frequency level. How will you explain that? Not the demographics, psychographics, but not the cluster analysis. Cluster analysis is a wonderful thing, ma'am, wonderful thing. But point here is, when we have dependent independent variable, cluster analysis will not be applied. That becomes Fmix. The same thing will become Fmix. My only submission is, first collect the data. Do collect the marker variable also and keep it aside. Don't take your marker variable here. After that, look at the structural relation. In the structural relation, make the structural relation in this diagram. I'm not saying make the CFA, make the structural relation and then work on the Fmix. Have you noted this thing? Please note this. Okay. Shahzada says, I am going to collect the data from the 3 regions. 90% of my population lies. Okay, firm level study. Firm is a single unit, only respondent. It will be feasible for clustering. Okay. If you are working, see, yes, there can be. Yes, there can be, Shahzada. The reason for that same is you say firm level response I will take. So will you go somewhere, there will be a wall that is called as firm, or will you talk to any person? Shahzada, will you, when you say I will go to a firm, what it means? There are some desk, bench, some wall is there, some building is there. You will talk to the building, hey building, give me the data, and building will give you the data, something like that. Or you will talk to the person. If you will talk to the person, whatever person may be, that's representing CEO, whatever, at the end, that is a person. Okay, so the person will have a frequency level. So there might be the chances a frequency level of the different CEO matches and others won't match. So it's apt to check there also. You should check there also. There are some people say, you know, richness is just a matter of time. So there are the people, if you have gone through the book of Rich Dad, Poor Dad, that says there are the two sort of the people, rich and the poor. There are the, it has nothing to do with the money. There are the people who don't have the money and they're still rich. There are the people who have the money and they're rich. There are the people don't have the money, poor, and they have all the money and still they are poor. Richness and poorness is my state of mind. I think Rahul Gandhi also read that book and said the same. So, but this book says richness, poorness is state of mind. So might be your CEO is again a person. The other common method variance and other effects might be there. No harm in checking. No harm in checking. You should check. Can I apply cluster analysis to classify patient? Pravesh, number one, please don't call it as cluster. Okay, let's call it as segmentation by phimics. Cluster simply says you take psychographics and then see which people are alike. Here I am not saying that thing, Pravesh. What I am saying, whether the structural model relation was found to be similar among the people. There's a way difference, Pravesh. Try to understand. Try to understand. If I'm selling some sort of my products, okay, so just look for this. I'm offering a club membership. So some is like very exclusive charges are there, very royal. Have you seen this gold card, platinum card, or that sort of card? So people who are buying the gold card, they are similar. Platinum card, they are similar in their needs, etc. Or some other copper card, they are somewhat similar. It means I have no dependent independent variable. I simply measured psychographics and made into that which category they will fall. This is one part. Now I'm going for second part. I collected the data, Pravesh. After collecting the data, I made the structural relation. After structural relation, now I'm trying to see whether structural relation is same for all the people or not. Now you will find no. For some, and again, you don't know these people, you don't know these are boys, girls. That part has been taken care of. That is observed. This is unobserved heterogeneity. Structural data. Structural data is mandatory. Now somebody will say, I got only one construct. Can I apply? No, you can't. Structural relationship has to be there. And then we will see whether the whatever the structural relation is there, is it same for the different groups? Are there any groups? Like in my case, it come out that there was no group. There's only all 100 people are almost similar. That's fantastic. Good error. But it might be different also. Okay. So don't use the term cluster analysis. That's hardcore term of marketing. There is no dependent independent variable. We measure psychographics. Here we have the dependent independent variable. Data has already been taken. Structural relation is there. And we are trying to see whether the relationship is same or not. You check it. If it comes same, go ahead with the routine one. But if it comes structural relation is not same, pause for a moment, think over it, why it is happening, and then how to go ahead with it. Think over it. When you yourself know not all people are the same, how can you go and say that all are the same? Let's see it. Might be it will be more clear when you actually see it. So just see it, how we'll do it. So let me close this SPSS. How many softwares I talked about? I talked about SmartPLS, G Power, SPSS, and now I will show you RStudio also. I request all of you, don't get attached to any software. Okay, like you're not attached to one way of eating. Sometime you eat South Indian, other time North Indian, other time something else, Gujarati, then this much, this much. So, and we feel happy with that. So this is a structural relation. Okay, so for quality lead to, and it's a very complex one, having lot many mediation, modation, etc. So now let me go for the data of 243. Make it as there is a select active data file. Now this is active data file. In one project, you can have n number of files attached, and right click and make it as the active data file. Now, whenever you work, 243 will be taken. How to go along? First, G power. I calculated with the G power. My independent variables are actually, I consider here as 1. But if I consider 2, it will be 55. You consider in your case. I'm just on the demo purpose, I am working with 1, 2, 3, 4 clusters and try to see what it will come out. So click on the calculate Fmix. In the Fmix, by default, I will say cluster number 1. It is iteration. By default, it's a very large number. I have reduced it to 100. You go with the default. Okay, I reduced with 100 because otherwise it will take a lot of time. By default, start calculation is not activated. Click it in once and then start calculation. It will work on it and it says it's done. Look for the, just have a look at the various clusters also. Sample segment size. Segment size, there is only one because only one cluster was there. Okay, fit indices, copy the fit indices, Excel, and take it to Excel then. One cluster, I have taken the data of the one cluster. So paste. And let me write this, not this. This is one cluster. Let me go for the second cluster now. Okay, so I can close it down. Fmix, where is Fmix? Here, 2 cluster. You need to do it with a very large number, 2000 or something, 5000. But the point is, if I do it 5000, it will be something like I will go take a cup of tea, come back. Till that time, it will processing. So 8, 9, 10 repetitions are done. Iterations are done for checking. 90% finished, done. Okay, how many people in each segment? So it says 56% and 43%. Fair enough, seems good. So fit indices, Excel format, and let's save it here. This is the data. Okay, let's go once again with the 3 clusters. So I click here on calculate, Fmix. Number of clusters are 3. Increase, decrease, start. It will take a little bit more time. You remember those sort of indicators? Upper limit is AIC, either this or low. MDL, minimum, either this or higher. And then 4 are there. 4 are there, AIC 3, AIC 4, BIC, and CAIC. We will use the pair. Try to find out minimum in all and then look for the pairs. If you go here, segment size, it's 62, 28, and 9% of the people. That's very low actually. 9% of the people are very low, but let's see what is the case here. So this is the data, and let me paste it for the 3. So I'm just showing you a demo. So let me do it for 4 cluster also. Okay. How will you decide how many cluster you will go with? You will decide total sample size 243 divided by minimum required. Minimum I required 55. So I should go up to 4. Certainly, if your data is large, number of clusters will be maybe 7, 8. Don't worry, AIC and MDL will narrow it down. It's not like you have to work on the all 7. It will narrow it down less than or equal to AIC, more than or equal to MDL, and in between, the other indicators will tell how many clusters to select. The same thing which is little tricky here, in POS it will be very simple. POS says no such thing, you take your own judgment where it makes sense. How many people are there, you just take heuristic basis and just work on that. Segment size, like 47%, 37%, 8%, and 3 and 4 are actually very narrow, very less number of people are there. If 100 people are there, only 8 people in the cluster, 7 people, too narrow. You can reject it on this basis. But if it's a large one, then not this. Fit indices, copy and paste it here. Okay. Now let's see how we'll go ahead with this. Okay. So number one, find out the minimum in each cluster. So let me use this function min in this and drag it. Okay. Number two, in all the value, now please highlight it, every minimum value. So 15, 19, 3, 2, 6, 2. So this seems in the, this is minimum in the third cluster. Do you get it? So wherever minimum, which value is minimum? Look for the row wise. 1622, this is the minimum. 1638.034, this is the minimum. 1651.47, this is the minimum. 1660.47, this is minimum. 1696, this is minimum. 1849.221 minimum. Minus, oh no, this is not required. Okay, so check it out for now. AIC says, look for the rules. AIC say, whatever the minimum value of AIC in whatsoever model cluster, either this or less. So according to AIC, 3 or less clusters should be there. Look at the MDL. MDL says 1 or more cluster is there. There is no rule that MDL will always come into the 1. No, there are chances it might come with 3, with 5. If you got 7, 8 cluster, it will give you either this or more. AIC will say either 3 or less. Okay, now go ahead, look for the rule here. The rules I have written here. Okay, go and show back. The rule says, if the minimum value of AIC3 and CAIC is in the same cluster, check it out. AIC3, it says 3, and CAIC, it says 1. Doesn't match. Okay, can't conclude anything. No problem. Go ahead. AIC4 and BIC. AIC4 and BIC, they are in the same cluster. Yes. So 1. 1 means there is only one segment. There are not many segments in my data. I'm relieved. I can go ahead with the data analysis. But I have found the cases where you will find 2 cluster, 3 cluster, 4 clusters. They are there. Let me assume this is a case of 3 cluster for a moment, though in this data I couldn't find it. But if we assume that there are the 3 clusters, how we go ahead with it? Shall we look at that? So simply go for this and run for the 3 cluster. So one more time, I will go. Not the PL. So you remember, it will give you model fit indices, how many people are there in every cluster, and it will give you which person will go to which cluster, which person will go to. So it will give you the idea about which person will go to which cluster also, cluster membership. So check it out here. It says segment assignment at the bottom box. It says segment assignment. And here it says this is the probability of which person will go in which cluster. This is sort of the machine algorithm. And now say discrete, these are the value. First person will go to first cluster, second cluster, and so on. Copy this and take whatever, wherever your data file is there. So where is my data file? Name of the data file was demo 243. So let me check. I think it's available on desktop. Not all files. It's a CSV file. Data 243. Will it open? Oh, it's not opening. So it might open by double click. Right. So now what we'll do? We'll come to the end of this. And here in the end, I will paste. So this been done. Now I have my every person, which person will go in which cluster. Okay, save it and close it. save and close. Right now, what I will do, I will come back to SmartPLS and then attach this 243 once again. I need to attach, so I need to delete it, or I can save it with other name. So right click on the diagram, it says import data file. Where is that data file? That's available here, 243, yes, go ahead and check it out whether the last one comes by membership. Final partition, see that final partition? Yes. Now you should know something about the multigroup analysis here. Again, I assume you know about multigroup analysis. Come to this file, see this is the diagram and this is my text file. You click on this text file. In the text file, and let's make it as active data sheet. Click on the generate data group. That is the case for the multigroup analysis. It will say, shall I create it? Yes. GR, with the GR, you click it, and on the final basis of final partition. Okay. And now just simply say, I've not done it anything else. Simply I clicked on generate data and I have given on what basis I should select. And I have given a number like GR or something. So check it out. In my data file, this was the all by summary. These are the correlation among the data, raw data. Another group is there, data group. And these are there. In the first group, there are 180 people. Second, there are 40. Third, there are 23. Not very encouraging because this is very high. These are less. So let me give their name so that I need to, this is 1. Let me give its name as 2 because this name is very, very lengthy. Or you can give any meaningful name on the basis of whatever name you have given to those clusters. And edit, this one comes out as 3. 3 clusters are there. Now you need not to do anything. Simply go and run anything and you will find that will be computed for all the groups. Oh, that will be computed for all the groups when you ask it to compute. So let me ask it to compute. Go to PLS algorithm. In that, the third one is data group. Till now we were not touching anything. So now touch on it and tell it select which one. 1, 2, 3. You can select any 2, you can select 3. Let's see. Now it will do it for differently for group 1, group 2, group 3. And check it out now. Below you will find complete. So let me see the R square. Behavioral intention 54%. Why so? Because behavioral intention get the data from all of the 3. That's why 54%. Loyalty 41%. Satisfaction 45%. Okay. Now just see next. In the group it's 77, 41 and 68. Quite strong. Go to the next. In the group 2 it's 52, 29 and 84. Go to the next one. It's 51, 65 and 4% only in the satisfaction. Go to the next one. It's 45. So if you don't segment, you will say 45%. But can you see, look at the segmentation only. It's 45%. In the group 1 is 68%. Group 3, it's 84%. And group 2, it's only 4%. How will you justify that? Well, this is okay. By chance, there was no grouping. But if there is one, then you should report it that not all the people are same. There are the clusters available. And this is other than what you thought of known sources, gender, age, place you belong to. Other than that, this is on the basis of the response pattern for the structural relation. So Pravesh, coming to your question, can you do it with the clinic, patient? I never said about clinic, patient. I simply said, look, there must be reflective scale. Second, the reflective scale must be having several relationships, structural relationships should be there, 2, 3 for minimum 2 and then 3 for etc. And then you try to check whether the structural relationship is same for all the people or it is different for the different people. This is your checking. So then you report it that the segments were found. You correct your sampling design once again. You said that initially it was thought that all people are same, but then we found that they are not same. There are actually some sort of variations, and this much, if you can gather anything about those people, if you know about those people from demographic characteristics, you know, some of the time you will find that maybe they belong to this particular institute, they belong to this type of, or a combination. People who come from Delhi public school and working in the Infosys sector, and this, they think this way. People who come from military background, they think this way. So these are those sort of indicators which you could not have thought otherwise. Now, can we do moderation analysis in SPSS? Yes, 100%. Why not? You can take this new variable, because now you know this variable is something. You can take it as the moderator variable and work on it 100%. At least you know this is the reverse case actually. In the moderation, you have a moderation and you have doubts whether this will have an effect. This is a reverse engineering. First, you know these are having an effect, and then you are calling it as the mid-order. Otherwise, Physics procedure is telling you these are the groups which are different. So analysis has been done, and now then you come to know that, okay, what are the groups? Moderation, you know the groups, and then you check whether there is effect or not. So this one is the, hope it makes sense now. It's something like when you come into the PG, then you better understand what the guys in UG are doing, and then you think better. When you are in PhD, you understand better this could have been done this way, or people are not looking at it. When you become assistant professor, you look for, actually the people should do like this. Actually, life is best understood in the retrospective mode, but it has to be lived in the prospective mode. So with every single day, we learn new things, we get new things, and every day the softwares will come, things will come, but ultimately it's on the basis of common sense. Do remember that. It's common sense based. It's not something like you do anything and it's simply the numbers or no. The main thing is coming back what I told you in the morning. These are the mandatory part, but these are as good as in an army. There is a medical corps, there is a Russian supply corps, there is some sort of other engineering corps. Main variables are the same. Main variables which are driven by the theory, which are driven by the experience. You work with these variables in detail. Main variables they require, but I am discussing this entire workshop except day 1, particularly about the day 2 also. Sandeep will also not discuss about these things. My point is only about the how part, robustness, structural robustness. Now, if anybody has, I won't use the word enlightened, but if you understood the concept of common method biasness, you will always have a doubt that whatever I'm measuring, it's not the real thing. Okay. Likewise, you are never sure that whatever data I have collected, this is all homogeneous. This is simply your belief. This is simple your assumption. May be true, may not be true. There is no harm in checking it once again. So that was about this. So let me quickly show you how to do it in RStudio. Those who are familiar with RStudio can see it. It's so simple. And then again, I may come back to the POS, prediction oriented segmentation. That's another part also. But I strongly feel that let me show you in RStudio. So, well, this is the interface of the RStudio. Those who have never seen it, it's just like 4 panes are there. These are the 4 panes. Let me remove this. This is part 1. This is part 2, part 3, part 4. One is called as the Untitled. This is just like a notepad file. I will write here. Here I will import the data that will come here. There is a import data set button here. I will import the file. R says I don't have any sort of input mechanism. You input your data anywhere. May it be text file, CSV file, Excel file, SPSS, data file. I can take from the websites also. You tell me my data is there. I will fetch the data. And again, I don't have the mechanism for saving. If you say, I will send it to Word file, I will send it to HTML file, to the PDF file, whatever you will say. So R says, I'm a fantastic calculator. I'm a calculator. Okay. No data entry, no data saving, only calculation part is there. And on this pane, a pane is a portion of screen is called pane. 4 panes you can see here. The 4th one is about the packages, how many packages are installed. So help, viewer, plots, etc. Graphical output will come here. I will write certain things here. When I write something, when I press enter, the graphical output will be here in plot or viewer, and the text output will be in the console. Console is just like output will come here. This is the output, this is the input, these are my imported file, and this is help and the graphical output. 4 panes are there. Now I am opening the file. The name of the file is, we are discussing about the Physics So let me recall, where is my file? Must be there in PLSPM, and it's PLSPM rebus. Okay. Don't see it like is it sort of programming or code I have written? Nothing like that. It's a very simple thing. So first thing is, let me import that file, demo file. So import from Spss. So where is my data file available? Browse. So demo, I hope this should work. Is it a valid? Okay. Is it a? It's a CSV file. So let me go with read R. This is to open first one base to open the text file. Second one to open the CSV file, Excel SPSS. So I have a CSV file. Let me try to open this way. So taking the data, and last one comes out as scores, etc. Done. Import. This is my file. I can see that just like Excel like format, I can see the last variable is behavioral intention, etc. Okay, this is the case. And first three is age, profession, income, gender, and so on. Okay, so let me go for Pls demo, this one. So how we start here? We start with, there is a package. For every single thing, there is a package. In R, there is a base package, and then there are multiple packages. Whatever you require, you simply call that package. We call them by require. So require package is made by Professor Gaston Sanchez. Here we can use everything what we get with file. I have imported the file, but you need to attach the file. So there's a command, and mind it, see how wonderful it is. We simply write ATT, and then a drop menu will come. So 3 alphabets you need to write. The similar way you need to write in Excel also. So press tab, and there here the bracket closes also, and then the demo file. Okay, so we writing part is very fast. Attach demo, it's attached. Now it says you need to make a diagram. So you need to make a diagram, and this is really fun. Very complex things we will do just in fun. For example, my data is quality leads to satisfaction, and satisfaction leads to loyalty, and quality also leads to loyalty. So you need to make it into this. I will write a matrix form: quality, satisfaction, loyalty, quality, satisfaction, loyalty. We will study it as effect of these on these. So look at the arrow, where the arrow is going. Arrow is going from quality to satisfaction. Quality to satisfaction, write it as 1. So arrow is represented as 1. That's it. So you remember in the Amos, you make the diagram, you enter, nothing like that. It's so fun. Satisfaction to loyalty. Satisfaction to loyalty, this is 1. Then quality to loyalty, this is 1. Only 3 arrows are there. So I will write the 3 0, and rest all are 0. Now this sort of matrix you need to form. Any complex diagram, simply 0 and 1. So simply remember, as many arrows are there, you will put as many arrows in your matrix form. And now how I will write it? I write quality is equal to C, a concatenation 0 0 0. See, this is 0, 0, 0. Next, satisfaction is equal to C, 1 0 0, and loyalty is equal to 1 1 0. Defined all three. Enter, enter, enter. R-bind means says that put them all the 3 together, putting into an envelope. Put an envelope. Now, if you just see what is meant by X so far, so it will say, just see it here, 0 0 0 1 0 0. It's a sort of a matrix. Okay. Now here you can see row got the name. There is a name of quality, satisfaction, but in the column there is no name. So I have written col name is equal to row name. These are optional things, but let's do it. Done. And now if you see what is X, can you see it's just like the diagram I made, quality, etc. So I am basically representing the diagrams into a matrix form consisting of 0 and the 1. But if you want, it can show you into the graph portion also. See, this is the graphical part. Is this what you are looking for? So it says one is quality, quality leads to, look at the arrow, quality leads to satisfaction, quality leads to loyalty, satisfaction leads to loyalty, right? So now if you, those who remember about the Amos, etc., you need to get these boxes and drag the value into the boxes. No such thing here. So what we will do, we will simply write in my data file quality is where? Quality consists of certain statements. Where is that? So look at my data file demo. So 1, 2, I'm just reading column number. 1, 2, 3, 4, 5, 6, 7, 8. Hindi is 9. 9, then 10. So quality is there in column number 10, 11, 12, 13, 14, 15. 10 to 15 is the quality. So I have written here as out is equal to list. I must write it as 10 to 15. That is my quality. Where is satisfaction? 1, 2, 3, 4, 5, 6, 7, 8. Hindi is 9, 10, 10, 11, 12, 13, 14, 15. So 10 to 15 is quality. Loyalty is 16, 17, 18, 19, 20. Loyalty is 16 to 20. Loyalty, see in this order. Quality 10 to 15, loyalty 16 to 20, and satisfaction, where is satisfaction? After 20, it's 21, 2, 3, 4. 21 to 24. So 21 colon 24. This I have given the values. Okay, and this is the command. Command is PLSPM demo, which is my file, X, which is my diagram, out, which is my order in which I have given. Where is my my file? Where are the number of the items? Where are the statements for every construct? Comma means next one. 10 to 15. Like look at the order. Let's minimize it. Quality is from 10 to 15. Satisfaction, it is from 21 to 24. Loyalty, it is from 16 to 20. That's okay. And now I have written, it's a 4 things. There is one more thing here. Just like SmartPLS, this also helps you in reflective as well as formative. Both you can handle. Both sort of constructs you can handle. By default, it is considered every construct is reflective. If you want to, there is a keyword called mode. I'm taking it as all reflective as of now. So demo is my file attached. X is my diagram. And see, this is my diagram. X, this one. Out means the positions and ski means path. I can use factor, weighted, so many things are there. So let's run it. It's XX1 and summary. And just see it out. Check it out in the summary. Everything that you check it out. Let me increase its size and summary. Let's see it from the top. Number of cases are 100 in the file. Latent variables are 3. Total manifest variable. How many items are there? 15. Standardized data. Non-metric PLS, no. It supports a non-metric also. We are using metric. Weighing scheme is path. Tolerance is 10 raised to the power minus 6. Maximum mutation 100. Convergence this. Mode A means all are reflective. Mode B means this is formative. Look at this. All are mode A. Cronberg alpha. Only for mode A, Cronberg alpha and these are computed. For mode B, weights are computed. These will be blank. Alpha is good for all. DG row is good. This gives you additional thing about eigenvalue. For eigenvalue 1, everything should be more than 1 and others should be less than 1. So it's good. Unidimensionality is there. Convergent validity hold true. Outer model. Now this is for the weight. Okay, and these are the loadings. Remember, these loadings are required for computing the AVE. Remember, these are the loading required for AVE. And community redundancy not required. So you can come, these are the cross loading. Just to check the cross loading, every item in its construct should be highest, in others it should be low. That's okay. Inner model, quality has an effect on satisfaction and T value is 4, P value is very, very small, good. And quality has an effect on loyalty, yes. Quality, satisfaction has an effect on loyalty, yes. Correlation, so this can under root, this is AVE. 0.605634568, and under root of that, if you put here, that becomes Fornell and Lacker criteria. These are the variables. This is the R square, 19%, etc. block community. Goodness of fit is 47, and this is the final relation. Final relation comes out as quality leads to this indirect effect, direct effect, etc. If you require, it will compute you bootstrapping and that part, that also it will give. It will give you all whatever you can desire of, including those sort of EPMA and others, it will give you all. Now you require is a simple function called rebus.pls. I will use that. So this output xx1, let me put it into the xx2 rebus. Okay. So this is done. And now it is asking for, please tell me how many, it's asking for a number here. It says how many clusters I should make. Let's say 2 clusters. Let's check it out. Done. It says I have done it. Now check it out. Let me run xx2 and again it will give you a lot of things. xx2. It says 2 segments are there. Okay, number of segments are iterations are this. Any size given. First it's a 37. Second there are the 63. In the class 1, see, path coefficient is 0.91, other one is negative. This is really challenging. Quality leads to satisfaction. In the first group, for 37 people, it was 0.9, perfect. For second group, these are 63 people. Actually, there is a negative. Good quality will lead to less of the satisfaction. Very strange. Look at these loadings are given, quality is given, average R square, etc. Shall I check it once more for xx2? Let me walk with this, and this time let me go for 4 clusters. Okay, said I have done this, computed. Let me remove that. I am asking it for make the 4 clusters. It said too many units with the 6 was detected. There are so low clusters with less than 6 people. It said sorry, not comfortable, no problem. Let's go along with the 3 clusters because I want to show you how we check here which cluster is best. Okay, now 3 clusters are there. Which one is better? Look at the GOF value. Whose value is highest? If you look from the top, in the first cluster, there are 45 people, second cluster, 17 people, third, 38. Well, size is very less, only 100, sample size is 100. So it said out of this given, how many clusters I should believe, whether 1 is okay, 2 is okay, 3 is okay, how to decide? This simply says, look at the goodness of it, whose value is highest among all clusters. So from it, we will say, take the 2 clusters, that's it. Take the 2 cluster, that's it. So now you can run it one more time, the last time, and you say it, run with the 2 clusters, 2, that's it. Now this output you will report, xx2, this output you will report, average commonality, average residual, R square. See in the first one, R square for satisfaction is 83%, second it's almost 22%. R square for loyalty, it's 82%, it's 37%. Can you see cluster 2 are not really very pro for this your model. Cluster 1, 37 people, they are almost very hard. If you don't believe it, the results will be something else. So this is how you do it in PLSPM package. I will not explain the PLSPM package because it's a complete word in itself. So what I will ask you, you go for here again. I think I'm doing my marketing. It seems like to this. Go for this Neeraj Kaushik PLSPM, and PLSPM package is there. I have explained how to download it. This is Professor Gaston Sanchez, working with the University of California, Statistics Department. Fantastic person, written so many books and giving all free of cost. So these are all the videos where you can download and go through. Data files are given along with this. Just go through it. You will just enjoy. No prior R knowledge is required. You can do it very, very fast. Simple commands are there, 3 or 4 commands you can do very fast, and every single thing like you can do for mediation, moderation, parallel mediation, serial mediation, multi-group analysis, interaction effect, heterogeneity, higher effects, second order, or etc. Moderated mediation. It's all about making that sort of matrix. That's it. Nothing more than that. So it's that's much simple. R code available in your channel? Well, yes, R codes are available. Those files are available. You can download. I give that data file, R code file, and you can run. And online support also. Any problem, write a mail to me. I will be happy to help you.